RCHUB International Foundation for Research and Education, an ISO certified.
Topics, that is significant relationship test using correlation analysis and the significant impact that test using regression, and then all different types of t-test. Okay, so let's get started. Let me share my entire screen. Okay, is my entire screen visible, ma?
Yes, sir.
Okay, so now let me start with significant relationship test. Significant relationship test. So, I mean, during the very first class, I told, right? If two variables are metric in nature, what is metric variable? Any variable that deals with numbers, or if any variable that deals with Likert scale based options with more than 60 plus respondents. So that is what is called as the metric scale. So now let's take a look. So when it comes to, yeah. So when it comes to variable one, sorry, let me increase the font size. Okay, so variable 1, variable 2, and significant what and test. So if variable 1 is metric and variable 2 is also metric, then we need to perform significant relationship test using correlation analysis. If there is a significant amount of correlation between the two variables, if there is a significant amount of correlation between the two variables, then we can perform the significant impact test. We can perform significant impact, or we can say it as significant influence. Both meaning same are using regression analysis. Okay. So now let's start doing it. Now I have considered the data set, this data set, the agriculture product export. I wanted to know whether the agriculture product export in terms of money, because when we export, we will be getting the money, right? This money and the quantity of agriculture product export are having relationship or not. You see, both are metric data. Both are metric data, both are numbers. So now I wanted to know whether the quantity of export we are doing with respect to agriculture product has a relationship with the money we are getting it or what. So in order to do the correlation analysis, what we have to do is that we need to click the analyze. We need to click the analyze, and then we need to go to correlate, and then we have bivariate correlation. Bivariate correlation. In the correlation, you need to select the variables for which you need to identify whether there is significant relationship or not. So I'm going to put these two variables, that is agriculture product export in terms of rupees and agriculture product in terms of metric ton. So there are different types of correlation. We can also do correlation for categorical data using Spearman correlation, but I'm not going to teach you right now. During the extended SPSS session, that is if there is going to be a 5 days or 6 days SPSS session, at that point of time, I will be teaching you elaborately about different types of correlation that has been available. And apart from that, there are other things what you can do using SPSS, like exploratory factor analysis, the cluster analysis, and reliability statistics using Cronbach alpha, which is very fundamental, that I will teach you. Okay, so as of now, let us stick on to our curriculum, that is the univariate analysis using univariate analysis, the bivariate analysis, and the multivariate analysis. Okay, so this is a bivariate analysis, which means we are comparing two variables, one against other. If two are metric variable, what is it the condition? If two are metric variable, we need to perform significant relationship test using correlation analysis. using Pearson correlation. The Pearson correlation box is will be all by default will be checkbox. Now you need to click OK. So now we have got the output. We have got the output. So this is the output. How to interpret this output? To interpret this output, first of all, we need to look at the significance value. So let me open the Excel also, so that you may easily able to understand. Okay. So I have copied this table. Now I'm going to paste this table in the Excel sheet. So now let's take a close look at the values. Okay. How to interpret these values? The very first thing what I told is you need to look at the significance value. What I said, very first thing you need to look at the significance value. Where is the significance value here? This is the significance value. This is the significance value. So we can consider any one thing. Okay, both will be same. So agriculture product export in terms of rupees and in terms of metric ton. So we found that there is no relationship. I told you, right? If the significance value, if the significance value is greater than 0.5, if the null hypothesis have brought more than 5% evidence, null hypothesis will be accepted. It means what? There is no significant relationship between the value of export and the quantity of agricultural product being exported. There is no significant relationship. So if there is no significant relationship, we cannot perform regression analysis. Okay. So how much is this relationship? In order to do that, in order to measure that, you need to look at the Pearson correlation value. So here it is meaningless because once we have found that there is no significant relationship between the two variables, it is meaningless to look at the Pearson correlation value. But in case if the value is less than 0.05, if the value is less than 0.05, at that point of time, this Pearson correlation value becomes meaningful. So let me tell you, if consider this value is less than 0.05. Consider this value is less than 0.05. So we can say that this of agricultural product export and the agricultural product export in terms of metric ton has a relationship. To what extent? To 39.5% they have relationship. They have somewhat weak relationship. So this is how you have to interpret. Actually, this is old data. Let me open a new data set. Okay. In new data set, you will be getting or else. Okay. So this is how you have to interpret. Let us consider another example. Let us consider this data set. Let us consider this data set. This is, I told you, right? Either the data has to be a metric data, I mean, Likert scale based question data, or it has to be the number. In number, we have found that there is no significant relationship. Let us check out with some social science, I mean, with this data collected using questionnaire. Yeah. I wanted to know whether the technical expertise, problem solving skill, adaptability, and communication, these all skills are interrelated or what? These all skills have relationship with one another or what? So let me do a correlation analysis for this. That is AB1 to AB4. Okay. So click on analyze, go to descriptive go to correlate, click on bivariate correlation and select the variables. Select the variables. That is AB1 to AB4, right? AB1 to AB4. Now I'm going to click OK. Great. Now we got the output. You see, You see, here the significance value is less than 0.05. That is 0.000. Then we can say that the technical expertise skill and problem solving skill are related to one another. They have relationship. To what extent? That is 0.313. That is 31.3% relationship. Similarly, the adaptability skill and technical expertise have relationship because the significance value is less than 0.05, which means we can say that they are related to one another by 21.7%. That is Pearson correlation 0.217 represent 21.7% relationship. These are weak relationship. Now I tell you. So let me copy paste this data set into here. Let me increase the font size. Is my Excel sheet visible, ma?
Yes,
Yes,
sir.
Okay. So now let's look at the significance value here. Here, all the significance value are less than 0.05, which means green signal. Green signal, and we can make use of this Pearson correlation value. You see? Ma, choose any one triangle, ma. See, technical expertise, by technical expertise will always be one. That is the diagonal value will be always one. That is problem solving by problem solving will be one. So that is anything divided by say the same thing is always one. So the diagonal value will be always one. Choose whether upper triangle or lower triangle because both the values are same because it gets replicated. For example, the technical expertise against a problem solving is 0.313. The same thing will be repeated here. Technical expertise against problem solving is 313. Similarly, adaptability against technical expertise is 0.217. Similarly, if you see technical expertise against adaptability is 2.17. So any one triangle, the upper triangle or lower triangle is more than sufficient. Let us consider the lower triangle. Any one triangle is okay, either upper triangle or lower triangle. So we can say that the technical expertise skill and problem solving skill are related. They have relationship with one another and they are related by 0.313. So now I tell you, in case if your relationship is less than 50%, then we should say that as weak positive or negative relationship. Weak positive or negative relationship. In case, excuse me, yeah. In case if it is between 50 to 65%, then we can say that, yeah, moderate positive or negative relationship. If it is between 66 to 85%, we can simply say that it has positive relationship or negative relationship based on the sign here. Here everything is positive sign. So we will say positive relationship or negative relationship. Okay. If it is greater than 85%, if it is greater than 85%, we could say that there is a strong relationship, positive or negative relationship. So this is how you have to interpret, ma. With respect to correlation, in order to perform a correlation, what you have to do, you have to, sorry, yeah, you have to click the Analyze tab go to correlate, click on bivariate correlation, select the variables. This is multivariate analysis. Last time what we seen is only two variables are compared. Only two variables are compared. So it means it's bivariate analysis. In case if you are going to do with more than two variables, at that point of time, this correlation becomes a multivariate analysis. So multiple variables are considered and analyzed. So if you are here, if you see the output, we have found that the significance value is less than 0.05, which means they are related to one another. So this is how you have to interpret. How to interpret? We need to look at the significance value. If the significance value is greater than 0.05, the null hypothesis is accepted. What is null hypothesis? There is no significant relationship. But in case if your significance value is less than, if your significance value is less than 0.05, the null hypothesis is rejected. Rejected in the sense there is significant relationship between the variables. You see here the significance value is less than 0.05, that is 0.000. So there is significant relationship between the variable. So is the concept of correlation clear, ma? Can we move on to the regression analysis? Students?
Yes, sir.
Okay. So now let's move on to the regression analysis. So regression analysis, let me do first with the bivariate itself. Actually, here it won't be coming yet. I will do and show you. I told you, right? Because only if there is a strong correlation, positive or negative correlation, you can do the regression analysis. It will be meaningful. Because the R square value is completely depends upon the R value, which is the Pearson correlation value. The R square value should be greater than 0.6. I tell you what this is. It is a forecasting accuracy. I will show you. Okay, let me start doing this particular data set. So in order to do regression, see, even in regression analysis, just like in Pearson correlation, there are various types of regressions. We have exponential, we have sine, we have power, we have logistic regression, we have polynomial regression, quadratic regression, cubic regression. There are so many regressions, but we are going to learn only linear regression. Might be in the future elongated SPSS session, I will be teaching you everything. That also could be done using SPSS, using curve estimation. That is curve estimation in the sense, in regression, there is something called as curve estimation, where you can do different types of regression model. But I don't want to make things complicated. I want you to learn the fundamentals of SPSS and fundamental tools which covers 90% of the analysis. So if you are doing a research, what analysis what I'm teaching you right now will be predominantly used. 90% this will be used. Only 10% here and there, apart from this analysis will be used. So now let me teach you regression analysis. Okay, so let me do the linear regression. So in order to do linear regression, click on the analyze, go to regression, and then click on the linear regression. In linear regression, it will be asking you what is your dependent variable and what is your independent variable. Keep it clear, ma. Dependent variable is any variable that depends upon other variables. Say, for example, you are first exporting your goods, right? First, you are exporting your goods. Based on the quantity of goods you are exported, you will be getting the income, your rupees or dollars, right? So you are selling a good. Based on the quantity of goods you are selling, the money, the amount of money is determined. So here, agriculture product export in quantity is independent data. And the rupees, what we obtain is a dependent data. So whenever you're dealing with anything, you need to make sure that you know the dependent variable and independent variable. So in order to do regression analysis, select the dependent variable and independent variable. Once you are selected, click on OK button. That's more than enough. So interpretation of this is very, very important. Many scholars make mistakes with respect to regression analysis. Sometimes they uses demographic profile to perform regression analysis. It is statistically wrong, ma. I repeat, don't ever use demographic profile, that is categorical data, to know the impact or influence on the metric data. That is statistically wrong. So yes, SPSS will give you the output, but it is statistically wrong. So only if two data or metric, if there is significant correlation with one another on the two variables you are concerned, then only you can do the regression analysis. In that, one should be a dependent variable and another should be an independent variable. Or there could be a circumstance where there could be multiple independent variable, but only one dependent variable. That also I will teach you, ma. So how to interpret the regression analysis? So let me copy paste this entire table. Okay. Let me copy this entire table. So yeah, this is our output. Is the output visible to everyone, ma?
Yes,
Yes, sir. Yes, sir.
Okay, so okay. Here, what all the things you need to look? The very first thing is the R value and R square value. This is the first green signal, but we have not got the green signal. Here we have got the red signal. Okay, I will just highlight. Okay, then we need to look at the significance value, ANOVA significance value. Here also red signal. Here also red signal. Okay, okay. So I tell you, ma. So this R square value, this R value is nothing but the Pearson correlation value. This Pearson correlation value will be same here. You see 3.395. The same value is repeated here, 0.395, which means the quantity of product exported and uh, the amount of money we have obtained through export in crore rupees have 39.5% relationship. And 35 point relation, this when squared becomes 0.156. This 156 is very, very important. The R square value, the R square value should be greater than 0.6, which means your forecasting accuracy is 60%, minimum 60%. Okay. Then this is very, very important rule. First, you need to look at this. If this is not satisfied, your entire regression table is waste. Please do look at this value, because many times I have seen a scholar who making mistake that even without satisfying the R square value, looking at the regression estimate or equation is meaningless. Okay. Then the ANOVA significance value. The ANOVA significance value should be less than 0.05, which means the model is fit. Okay, let me put it here. Okay.
Doctor.
Coefficients the coefficient significance value. There is influence. Influence or impact. Okay. So first you need to look at the R square value. If the R square value represents the forecasting accuracy, let me repeat, R square value illustrates the forecasting accuracy. Your regression model should have at least 60% forecasting accuracy. Because if someone's saying less than, if his forecasting accuracy is less than 60%, it is not at all considered as a forecasting equation at all. So as far as the statistics is concerned, your R square value should be your R square forecasting accuracy, that is R square value, should be greater than 0.6, which means it should be greater than the forecasting accuracy should be greater than 60%. And then coming to ANOVA. The ANOVA significance value illustrate whether the model, what you have considered, the dependent variable and many independent variables or one independent variable, is fit or not. So is the model is fit or not? Here the ANOVA significance value should be less than 0.05. If it is greater than 0.05, your model is not fit. And your coefficients, the coefficients in the sense, this is coefficient. We know, right? Y equal to linear regression equation is A plus BX, where X is the time period, A and B are constants. Excuse me. Okay. So here the significance value should impacting the dependent variable. Now let's look at the regression value, the regression model, what we have created. The R square value is only 0.156, but the minimum R square value what we required is 0.6, which means this condition is not fulfilled. Red. If this is red, then everything is done. We know it is useless in seeing the regression model. And sometimes if your R square value is greater than 0.6, but your ANOVA significance value is greater than 0.05, you need to stop the regression model. Here itself it is stopped. You cannot go or proceed further. Here, if you see, the ANOVA significance value is greater than 0.05, which is once again red. So this model is not fit. In some cases, you will be getting the R square value, but you won't be getting the model fitness. There is no model fitness. At that point of time, you cannot consider this regression equation. And then we need to look at the coefficients, the coefficient significance value. If the coefficient significance value should be 0.05, only then we can say that this agricultural product export in terms of quantity is impacting the agricultural product export value in crore rupees. Here it is once again greater than 0.05, which means we can say that once again it is red. So there is no impact. So let us do another regression analysis using this data, the data. Yeah. Here I have these data. I wanted to do regression analysis. So in order to do regression analysis, go to analyze, go to regression, click on linear regression. Here I'm going to consider all these variables. Now I have to select the independent variable and the dependent variable. So dependent variable can be only one, independent variable can be any numbers. So here I'm going to choose training need analysis. So training need analysis depends upon the performance discrepancy. When there is performance discrepancies, we will do training need analysis. Similarly, we will do based on the task and job analysis, we will perform training need analysis. Based on the performance gap, we will be doing the training need analysis. So I'm going to consider training need analysis as a dependent variable, and performance discrepancies, task job analysis, and performance gap. These three variables as an independent variable. Now it's a multivariate analysis. Previously, what we have performed is independent bivariate analysis. Now we are going to perform the multivariate analysis, that is multiple regression. Previously, we have done linear regression, that is using just two variables. Simple linear regression. Simple linear regression means only two variables. This is called as multiple linear regression, but the interpretation is same. Then click on the OK button. Great. In general, actually, for secondary data, we'll be getting these kind of values, but it's okay. It's vice versa. Here for primary data, we are getting the. Oh, that's great. This model is completely fit. I think I need to make these data for my article. Okay, ma. So let me copy paste this. Okay. I'm going to copy paste the same table side by side, so that you may also understand the things clearly. Oh, sorry. Uh, is this font size okay, ma? Is it visible?
Yes, sir. Visible.
Yes, sir.
Okay. Okay, ma.
Yes, sir.
Okay. Now let us look at the R square value. First, what I said, we need to look at the R value and R square value. The R value is also great. R square value also super great. It's 0.815, which means green signal. We can say that our forecasting accuracy is 81.5%. That is superb. 81.5% forecasting accuracy. That's great. Then if you look at the ANOVA significance value, the ANOVA significance value should be less than 0.05. Here, once again, it's a green signal. The ANOVA significance value is less than 0.05. That is 0.000, which means our model is fit. Our model is just, yeah. Our model is fit. Model is fit. And super forecasting accuracy. Okay. And then if you look at the significance, the coefficient significance value, everything is green signal. Everything is superb, which means we can say that the training need analysis is dependent upon the performance gap of the employee, the task job analysis, and the performance discrepancies happening in the organization. All these three factors are actually impacting or influencing the training need analysis. This is how we need to interpret. Now you may have a question, sir. You told this is a regression equation. So where is the equation? So how to frame the equation? That I'm going to tell you right now, ma'am, because this is meaningful. I thought it won't come, but great. So our model is fit. Okay, so how to frame the equation? I told you, right? Y equal to A plus BX. What is A here? A is nothing but the constant, this B value, the beta value. Okay. So I'm going to put the value that is equal to, that is training need analysis. Let me put in short form. Training need analysis, TNA, is equal to what is this value? 0.112, 0.112 y plus bx. What is b here? Here there is b1, b2, b3 mark, because b1 is performance discrepancies, b2 is 0.262, and b3 is 0.297. Okay, so we could say that 0.412 into performance discrepancies, PD, plus yeah, plus 0.262 into task job analysis, TJ analysis. Okay, TJA, plus 0.297 into what is that? Performance gap, PG. So this is your regression equation. Using this, you can calculate the training need analysis. So you may have a question, sir, this is social science data. These are, how could I estimate? Actually, let me teach you with this, this model. Let me teach you with this model. Let me teach you with this model so that, so did you understand this? Did you understand this? These are the values here. These are the values here. Okay. In case if this particular significance value is greater than 0.05, say the performance discrepancy is greater than 0.05, I won't be using that in my regression equation. My regression equation will be simply 0.112 plus the performance discrepancy will not be there. Instead, plus 0.262 into training and job analysis, plus 0.297 into performance gap. Only the coefficients which is having significant impact or influence will be considered for the regression equation. If the coefficient value is greater than 0.05, I won't be considering that for my equation. Okay, ma? So here I will do it. Y is nothing but the export value. So export value could be anything equal to A. A is nothing but this value, plus B is nothing but this value, into let me consider the 11th period. So during my 11th period, that is, I will during 11th period, in the sense, I have considered 10 years of data, right? I have considered 10 years of data. Oh, I have considered okay, 17 periods of data. So let me put 18. What will be my that is during 2023. During 2023, what will be my yeah, here the forecasting is less. I mean, it's showing that I will be getting 3,785.4 crore rupees during the 2023, which is wrong because the forecasting accuracy is very less. But this is how you will get something meaningless. But using this, have you got it? Y equal to A plus BX. This is the regression model. If you put, you will be getting the values. If you substitute values for this, obviously you will be getting the value for training need analysis. This is how you need to estimate the regression equation. So with respect to regression equation, what all the aspects you need to see? The R square value, which should be greater than 0.6. The ANOVA significance value, it should be less than 0.05. Only then your model is fit. And then the coefficient significance value. Only then, if the coefficient significance value or less than 0.05, that particular variable is impacting the dependent variable. Is everything clear, ma? So I have taught you the simple correlation analysis and multiple correlation analysis and simple regression analysis and multiple regression analysis. So till now, is everything clear, ma? Do you have any doubts? No, right? So can we move on to the next?
Yes, sir.
Okay, now we are going to move on to significance difference test. So what is significance difference test? I told you, right? In significance difference test, if one data is categorical, and another data is metric, at that point of time, we need to do the significance difference test. Okay. At that point of time, we need to perform significance difference test. All T test comes under that. For example, independent sample T test. Then we have ANOVA. And we have one sample T test. One sample, we have paired sample T test. Okay, so we have these many types of T test. Okay, let me start with ANOVA. Let me start with ANOVA. Okay. Let us consider this age. Yeah, we have 5 options. Let me consider this option, the career opportunity. Oh. Okay, let me consider education qualification. Education qualification as one option and career opportunity. So in order to do the, because I want to know whether there is significant difference in opinion among the respondents with respect to career opportunity. How to say, is there significant difference in opinion for career opportunity with respect to educational level of the respondent? For that, I'm going to do the analysis. So click on the Analyze tab. In order to do ANOVA, you need to click on the Compare Mean. In the Compare Mean, at the bottom, the very bottom, we will see one-way ANOVA. So click on the one-way ANOVA. Okay. After clicking the one-way ANOVA, it will be asking you the variables. It will be asking you the variables. So now I'm going to select the variable. What are the variables I'm going to select? Education and career opportunity. So I'm going to click OK. Or not just career opportunity. Let me also click timely completion, change environment, growth of the growth of organization, all these things, because all these are the requirement. Okay, I'm going to click OK. So now I have got the output. So how to interpret the ANOVA output? ANOVA output is, you need to once again look at the significance value. We need to look at the significance value. If the significance value is less than 0.05, if the significance value is less than 0.05, then you can say that there is significant difference in opinion among the respondents belonging to different education qualification for the career opportunity, timely completion of project, change in environment, and growth of the organization. So there is a difference in opinion with respect to the employee with different education background. So employee with UG is telling different, is considering career opportunity in a different level. Employees with PG is telling career opportunity at a different perspective. So their opinion perspective varies with respect to career opportunity, timely completion. So this is how you have to interpret the ANOVA. So you need to look at the ANOVA significance value. looking at the ANOVA significance value, you can say that there is significant difference in opinion or not. So let me do another analysis also. Let me go for independent sample t-test itself. So independent sample t-test is the criteria where you can do only with two groups, two groups. Say for example, in gender, we have only two options, male and female. Here, if you cannot do independent sample t-test for age or education, marital status, you can do married and unmarried, only two groups. If you have only two groups, at that point of time, you can do, that is two categorical data, you can do independent sample t-test. If there are more than 2+ groups, at that point of time, you need to do ANOVA. So let us do independent sample t-test using two groups, that is gender and the career opportunity, timely completion, growth of the organization. Okay. So even if you select age or something, it will be asking you, what are the two groups you wanted to compare? In age also, if there are 5 options, you can compare only two groups. That is less than 25 or 25 to 35. Only two age categories can be grouped. So independent sample t-test can be done only for two groups. That is, one is male and second is female, right? I'm going to click OK. Here, this is complicated part. You will be getting 3 significance value, You will be getting 3 significance value. You see, here is one significance value, and there is here one significance value, and here one significance value for the career opportunity. Let me copy paste this in it. Yeah. Okay. So what significance value has to be considered? You may have a confusion. So you look at this significance value, it is less than 0.05. If it is less than 0.05, what it is rejected? That is, the significance value straight to this should be rejected. And this one should be accepted. This one should be accepted. And if you take this here, the significance value is less than 0.05, which means this particular significance value is rejected and this significance value is accepted. But in case here, it's greater than 0.05, that is, this is 0.05. No, that is 0.068. It is greater than 0.05, which means the significance value straight to this is accepted. You got me? So based on this first significance value, the corresponding significance value is accepted or rejected. Okay, so this is how you have to interpret the independent sample t-test. Let me delete all this thing. These are the important values. So we can say that for career opportunity, there is significant difference in opinion. For timely completion of the project, there is significant difference in opinion with respect to male and female. But for change in environment, irrespective whether male or female, because the value is greater than 0.05, right? There is no significant difference in opinion with respect to male and female candidates with respect to change in environment. For growth of the organization, once again, there is significant difference in opinion. So this is how you have to interpret the independent sample t-test. Is that thing clear, ma? So if there is only two groups, go for independent sample t-test. If there is 2+ groups, you have to go for the ANOVA test. So one sample t-test and paired sample t-test, we have very limited time. Okay. Let me open a new data set. Say, for example, mileage, Royal Enfield, RE mileage. Okay, before service, BS. Okay. The Royal Enfield, similarly, Royal Enfield mileage after service. Okay, AS. Okay. You have considered 10 vehicles. The first vehicle is giving 35 as the mileage. The second vehicle is giving 32 as mileage. the third vehicle is giving 36 as mileage, fourth vehicle is giving 38 as mileage, and then the next vehicle is giving 35 as mileage, and the next vehicle is also 35 as mileage. Then the next vehicle is 33 as mileage, 34, consider like this, 35 as mileage. So one sample t-test is generally done if there is a standard value. If there is a standard value. There is a standard value. So let us perform this one sample t-test. There is this. So in order to perform one sample t-test, click on Analyze, go to Compare Mean, click on the one sample t-test. So select the variable, that is this one, right? VAR, yeah, this one. And company have told that the Royal Enfield bike will on an average give a mileage of 35 km per liter. 35 km per liter. So we are going to check this. So if there is a standard value, the test value is nothing but the standard value, and you have a metric data. You have a metric data. Then at that point of time, you can do the one sample t-test. So I'm going to click OK. Oh, not bad. Okay. So you see, the mileage is 34.778. 34.778. And you see, which means it is less than 35. It should be around 34. It should be either 35 or it should be 0.25 difference is okay. Which means you see the significance value is there is a significant difference in the mileage. So if you have it's less than 35, right? So if the test value is 35 and if the number of sample increases, here the sample size is only 9. So even as very slight variation, it will under the significance level of 0.05, that is 0.05 as a, here it's 0.3, right? 0.3 difference is there. 0.05 means it will show there is no significant difference. So this is how you have to perform one sample t-test. But in case the company is climbing, let me put this also 35 so that after the first service, the company mileage will get increased by 3 km per liter. So let us put here 38, 36, 35, 35, 34, 37, 38, 38, something random numbers, 39, 36. Okay. Now I'm going to analyze. So with respect to paired sample t-test, it is a time before and time after. Say, for example, you are a sports person. You are giving a training to the person. So before training, what was his speed? After you giving the training, what is his speed? So when there is a same set of sample at two different time intervals, same sample, two different time intervals. At that point of time, you need to do the paired sample t-test. Let's see how to do the paired sample t-test. Click on the Analyze tab, go to Compare Mean, click on the paired sample t-test. Here, both the things are metric data. You may ask, sir, you told one should be categorical data and one should be metric data. Then only we need to do significant differences. Actually, if you go on inside here, you have inbuilt categorical data. That is inbuilt categorical data in the sense the sample before and sample after itself is a categorical data and its values are metric data. So that's why you no need to consider it doesn't follow this general rule of categorical and metric data. In independent sample t-test and one ANOVA, you have used one categorical data and one metric data. But in paired sample and one sample t-test, you already have a standard value, which is a categorical. That is a single value. Which you are going to compare against all the values you have. Here in paired sample t-test, the same set of sample before and after itself is a categorical data. Now we are going to compare it. So, okay. So before service, the average mileage of Royal Enfield is 34.8. And after service, it is 36.70, which means there is a slight increase in the mileage. So now look at the significance value. The value is 0.061, which means the significance value is it is greater than 0.05. It is greater than 0.05. Which means we can say there is no much significant difference in mileage before and after service, which means the company should concentrate on doing a better after sales service during the first service and second service to increase the mileage of the bike. So this is how you have to interpret, ma. So today we have discussed very important topics. Let me sum up. So today we have discussed about the very first thing, that is the simple correlation and multiple correlation. Then we have discussed about the simple linear regression and multiple linear regression. And then we have discussed about the independent sample t-test, which means you can use only two categorical data at a time against metric data. Then we have discussed about ANOVA, in which more than 2+ categorical data can be analyzed as an independent variable and metric data as a dependent variable. So then we also have discussed what is the criteria to do one sample t-test and how to perform the paired sample t-test and what are those criteria. One sample t-test should have a standard value, and the paired sample t-test, it should be same set of sample but two different time intervals. So is everything clear in today's session, ma? Do you have any doubts? Is everything clear?
Yes. Yes, sir.
So do
Sir, can you
anyone
just
tell me.
sir, good evening, sir.
Good evening, ma.
Sir, can you just explain once again the regression analysis equation, sir? Y equal to ax plus b. Actually, in that training period that you explained, can you just explain how you came to that calculation, sir? Just once. The last few steps, sir,
Sure,
of the
ma,
equation.
sure, ma. Let me share my entire screen, ma. Let me bring you the real data itself. Actually, I have done recently, so that you may better able to understand. Yeah, this is the one. Yeah. Yes. Yeah. This. Yeah. This. Okay. Is my entire screen visible, ma? Is my entire screen visible?
Yes, sir.
Okay, ma. Let me copy paste. Yeah, okay. Let me copy paste this one particular data set now. Okay, let me copy paste this one particular data set in a. This is India's export to Russia. Okay, this is India export to Russia. I wanted to do regression analysis. Let me insert another where I could put 1, 2, 3, 4. Sorry. Let me extend till 50. Okay. So I want to do regression analysis. So let me put it in the Excel itself. To do regression analysis, data analysis, regression. Click OK. Input range. Input X. Output range. Here. Click OK. So now I got the output. So my R square value is 0.875. Great. So let me try to forecast. So how to forecast? I told you, right? Y equal to A plus BX. So A is nothing but this coefficient. A is nothing but this coefficient. B is this coefficient. Okay. So these are the coefficient values. Now I'm going to substitute here and check it out because this regression equation is having 87.5% accuracy. So I will be getting somewhat accurate value equal to A, this value, plus B, this value, into X. X is 11. So I'm going to put $sign here. So you see, during the year 2025, we will be exporting 2,720.285 crore rupees of agriculture product export to Russia. Let me drag it down. You see, the agriculture product export to Russia during the year 2026, 2027, 2028, 2029. Easy, ma. Why? A is nothing but this value. B is nothing but this coefficient value, provided you need to make sure this significance, the coefficient significance value is less than 0.05. Here, it's less than 0.05. E power minus 0.5 means 10 into 10 power minus 5, which means it's less than 0.05. So this is how A plus B X. X is nothing but the period. Is everything clear, ma? Now you have got the concept?
Yes, sir. Yes, sir.
Very simple, ma. If in case if you are doing multiple regression analysis, it will be B1X plus B2X plus B3X. Like that it goes on. Okay. Anyone, any other questions, ma? Anyone, any other questions? Is everything clear? Okay, then. Okay.
Contact RCHUB International Foundation for Research and Education. WhatsApp 9888 231 231.